In this video, we're going to discuss color management. We're going to tackle fundamental theory, common misconceptions, and demonstrate actual workflows in DaVinci Resolve. Now stick with us, because in order to understand this properly, we do need to go through some fairly deep topics. This is going to be fun though, chapter markers below. Let's start at the beginning. Cameras capture images, displays display images. When light falls on a camera's sensor, it generates voltage. That voltage must then be converted to zeros and ones that can be stored on the camera's memory card. A display must then convert those zeros and ones back into voltages that drive the panel or projector's pixels. The only way this process produces a meaningful image is if the display understands the way that the image was encoded in the first place. A known and documented standard must govern this process. An effective way to illustrate this concept is with the analogy of language. We can both communicate via email because we both understand English. When I write an email, I'll translate my thoughts into written words using the English language. When you read that letter, you'll translate those words back into thoughts using your understanding of the English language. If you don't understand English, if another language is your mother tongue, you won't be able to understand my email. You might comprehend parts of my email, but your understanding won't fully reflect the thoughts I was capturing. In the digital world, those languages that we use to communicate images from one device to another, they are called color spaces. A color space describes a specific, measurable, and fixed range of possible colors and luminance values. A big thanks to Colin Kelly for that fantastic, concise definition of a color space. I couldn't say it better myself. Let's break that down. There's two components to any visual image, color and brightness. So there's two components to any color space, the way that colors are encoded and the way that luminance is encoded. In other words, regarding color encoding, what's the reddest red that you can store in this color space? What's the greenest green? What's the bluest blue? What about luminance? Well, because the way that we perceive light is not linear, luminance values are typically encoded with clever maths. For example, a gamma curve might be used to encode luminance in a way that more closely matches our perception. Or a logarithmic function might be used to maximize the amount of dynamic range an image can contain. Currently, the most common color space that we use is Rec. 709. Hopefully that sounds familiar. If my camera records a Rec. 709 image, and I play it back on a TV that is designed to play a Rec. 709 image, then within reason, I'll see a faithful reproduction of what my camera recorded. The reason this works is because that is like writing an email in English and reading it in English. But as you're probably aware, many cameras shoot in non-standard color spaces. For example, a Sony camera might record in S-Log3 sgamut3.cine. An ARRI camera might use ARRI-Log3. When you view a log image on a Rec. 709 display, it comes out looking flat and desaturated. That's because the camera is speaking a flavor of log, but the monitor is speaking in Rec. 709. That's like writing an email in French, but trying to read it in English. Furthermore, new televisions are capable of using color spaces like Rec. 2020. To understand why there are so many color spaces, we need to understand the limitations of Rec. 709. Rec. 709 was created and adopted in the early 90s. Nowadays, we think of Rec. 709 exclusively as a color space, but it was more than that. Its full name is International Telecommunications Union Recommendation Broadcast Television 709, or Rec. 709 for short. It contained standards for what at the time was the next big thing in television: high definition. It defined things like frame rate, resolution, and of course, color space. Now this has happened before. As always, economy played a big part in the development of this standard. If you're interested to see how it affected the shape of the image you watch, the aspect ratio, check out our video on the history of widescreen. Back to Rec. 709 though. Storage space is expensive. Bandwidth for transmitting video images is limited, so we want to encode images as efficiently as possible. At the time, most people were viewing television with CRTs. In fact, cathode ray tubes were the very finest in display technology. LCD and plasma technology was still in its infancy. Whatever the technology though, most displays were designed to achieve a maximum luminance of around 100 nits. There's also a limit to the colors these displays were capable of rendering. The same was true of the cameras being used to capture video. Why design a color space that can capture more colors and dynamic range than people will ever be able to see, or the cameras of the time could actually record? That would be like sending a 5.1 surround sound mix out to someone who is only listening on a mono speaker. As a result, Rec. 709 is inherently limited by the technology of its era. As camera and display technology progressed, the need for new color spaces that are capable of capturing more intense colors and more dynamic range emerged. Different color spaces are designed for different things. We're going to break them up broadly into three distinct categories. Rec. 709 and Rec. 2020 are primarily display color spaces. Yes, many cameras shoot Rec. 709 and Rec. 2020, but they tend to be consumer cameras like your phone or cameras designed for broadcast or electronic news gathering, where an image is wanted that's ready for broadcast immediately without any color management. Most log color spaces like ARRI log, Sony log, Canon log, they are camera or capture color spaces. For example, ARRI log is designed to complement ARRI's cameras and sensors. It's not intended as a delivery or display color space. It's optimized to juice as much information out of ARRI's sensors as possible. And then we've got color spaces like DaVinci Intermediate or ACES. We're going to call these scene color spaces. Unlike camera or display color spaces, a scene color space is not built around the limitations of a camera or display technology. Color spaces like DaVinci Intermediate or ACES are so large that they can, within reason, faithfully record all the visible colors present in a scene, regardless of whether a given camera can see them or a display can display them. So, what is color management? On a given production, you might have rushes in ARRI log, Red log, and Rec. 709. And be expected to provide two deliveries, a legacy delivery in Rec. 709 and a high dynamic range deliverable in Rec. 2020. From a practical point of view, color management can be considered as the process of reconciling all of those color spaces into an appropriate color space ready for delivery or archival. Color management is a workflow. It can be done manually or with the aid of tools designed to automate the process. There's three common tools for managing color spaces. My examples are going to center around using DaVinci Resolve. Method 1, lookup tables. Method 2, node-based color management using color space transforms, CSTs, or ACES transform. Method 3, project or timeline-based color management using DaVinci YRGB color management, or ACES. All three of those options can broadly be considered as color management. However, some of those options are more labor-intensive and can offer less accurate results. Let's talk about options. For many people, their first experience with color management is using a LUT to normalize a log image to Rec. 709. Lookup tables are an inherently flawed technique for color management. I'm not categorically saying they are bad or should never be used, but it's important to understand their limitations. Let's say your camera is shooting in a log color space, but you need to be able to view a normalized image on set. Or perhaps your DP and colorist have already collaborated on a look for the final video and would like to be able to view a rough grade on set. Your production monitor or camera has limited processing power because they are designed to be portable. A LUT stores a very simplified version of a color grade or color space conversion in a file that can be processed in real time by a portable device. As a result, LUTs prioritize convenience and portability over accuracy and quality. If you would like to see how to load and use LUTs in Resolve, check out this video. Now, one last thing to be conscious of. Not all LUTs are created equal. Some do bad things to your image. Others work fantastically. Anyone can make them. Even if they're made well, their title or the comments contained within might not give a complete image of what that LUT does. A color space transform or ACES transform is a much better way of applying a color space adjustment to your image. Instead of applying an approximate change to your image like a LUT would, CSTs or ACES transforms apply a proper mathematically accurate transformation to your image. Additionally, these tools provide advanced controls for refining these color space transformations. The downside of using these CSTs and ACES transforms is that while it can be sped up by using node tree templates, it requires the colorist to manually set up their color management using nodes on each individual clip. They add more power, but at the cost of convenience. Project-based color management, or what most people call just color management, solves some of these problems. It uses the same powerful maths that's in those CST and transform tools, but hides it in the background. Instead of configuring your color management on a per-clip basis in your node tree, it can now be configured globally in your project or timeline settings. Additionally, most new cameras now embed color space metadata in their files. Resolve can use this to automatically apply the correct conversion to each clip. Then, all you need to do is tell Resolve what color space you are delivering in. In its most basic form, color grading is just maths. To make an image brighter, the numerical values stored for each pixel must have their values increased. To remove red from an image, the value representing red must be decreased while the values representing blue and green must be increased. Each color grading tool manipulates those values using different mathematical formulas. Here's the question. Should those mathematical operations be applied to the image while it's in the camera color space or in the delivery color space? In other words, what color space should I configure my timeline to? Grading in the display color space is called display referred grading. Before the advent of digital cinema cameras, this is how most people worked, especially given that most cameras were already recording images in the display color space, Rec. 709. Grading display referred can be a fine way of working in certain scenarios. For example, if you only ever work and deliver in one color space. But it's not a future-proofed workflow and will cause compatibility issues as you transition to other color space deliverables. Grading in the camera color space is sometimes called scene-referred grading. But for the sake of making this explanation clearer and more explicit, I'm going to be brave and call that camera-referred color grading. Grading in the camera's color space does have some advantage over display-referred color grading, as the camera's color space generally has a wider gamut and dynamic range. When people normalize images with LUTs, you'll often see primary corrections applied camera-referred. That basically means to the left of the LUT. And secondary corrections are sometimes applied display-referred. That means to the right of the LUT. That's a consideration that's made because of the inherent limitations of the LUT used to normalize the image to the display color space. One of the problems with this workflow is that color grading tools will respond differently in different color spaces. So, for example, a color grade that's created in RE-log-C will not translate when copied to a shot that has been produced in a red color space, for example. This brings us on to our third option. Using a color-managed workflow, or perhaps node-based transforms, it's possible to convert your capture images into an intermediate color space before then converting them into your display or delivery color space. DaVinci Resolve has a color space specifically designed for this purpose. It's called DaVinci Wide Gamut Intermediate. ACES has their own too. In fact, they have several, but they both work in a similar way. They are super wide gamut and super high dynamic range color spaces that are capable of storing more colors and more luminance than any typical camera color space or display color space. In other words, they won't create a bottleneck in your color management pipeline. A typical project might look something like this. Footage has been captured on a mixture of RE and RED cameras. Those images are converted into DaVinci Intermediate. Then finally, before being sent to my monitor or rendered, the images are converted into the display's color space, in this instance, Rec. 709. When working scene referred, my grades are performed in the DaVinci Intermediate color space. Why do we call this scene referred color grading? Because in the process of converting the image into that intermediate color space, Resolve has undone all of the peculiarities that each camera baked into the image by using their own color space. In this scene-referred workflow, the image now more accurately represents the light that was present in the actual scene. In a scene-referred workflow that uses a wide gamut, high dynamic range color space, we eliminate the problems of camera-referred and display-referred workflows. This workflow is compatible with future high dynamic range and wide gamut deliverables, and color grades can be copied and applied consistently between footage that has been shot on different cameras. LUTs are a poor option for scene-referred workflows. So, should you use node-based manual color management or Resolve or ACES project-based color management? Node-based versus project-based isn't a choice of quality. Within reason, they can both deliver the same high-quality image. This is more a question of convenience. Node-based CSTs and ACES transforms do offer more flexibility, as each conversion can be tweaked with the additional settings that are not exposed when using the project-based color management. However, in the majority of scenarios, that kind of granular control is not needed. Node-based workflows can add unnecessary complications to your grading workflow. Well, fortunately, you can have your cake and eat it, because it's possible to combine the advantages of node-based color management with project-based color management in one simple, convenient workflow. Enough talk, let me show you how. Here's a brand new project. Head to Project Settings, Color Management, and change Color Science to DaVinci YRGB Color Managed. Please note, the process is broadly similar if you use ACES. Uncheck Automatic Color Management and change Color Processing Mode to Custom. There's three main things that we need to set up: our input color space, our timeline color space, and our output color space. This first setting, input color space, often gets people confused. Here's the solution. Instead of calling it the input color space, think of it as the default input color space. If Resolve cannot automatically identify a clip's color space, or you've not configured it manually, it will use this setting as the default assumed color space. I'll set my timeline color space to DaVinci Intermediate, and I'll configure my delivery color space to Rec 709 Gamma 2.4. I'll head to the media page to import my footage. These red files contain metadata that Resolve has been able to use to correctly identify their color space and apply the correct transformation. These ProRes files don't contain color space metadata. In that scenario, Resolve has assumed that they are Rec 709. Remember, that's the default we left configured in the color management settings. That's why they are displaying incorrectly in my viewer like this. So I need to configure their input color space manually. I can configure all of these clips at the same time by selecting them before I right-click. Head to Input Color Space and select the right color space. These are filmed with ARRI Log C3. Now you can see they are being correctly color managed. I'll insert a handful of these clips into a timeline so I can demonstrate the color page. Now let's head to the color page. Any corrections I create in my node tree are being applied in the DaVinci Intermediate color space. So this is scene referred color grading. Because I'm working scene referred, I can copy color grades between different cameras and expect relatively consistent results. For example, here's a color grade I've already created and saved as a power grade. It provides relatively consistent results whether I'm applying it to a clip that has been shot in ARRI's color space or Red's color space. If I'm required to create multiple deliveries, for example a HDR deliverable, I've got several options. Here's a method that I like. Duplicate the timeline and then go to Timeline Settings. In the Color tab, you can see that this timeline is currently inheriting the color options that were set up in Project Settings. By unchecking this box, I can now configure this timeline separately. I'll change the output color space to Rec 2020 ST2084. Now I can use my SDR grade as a starting point and adjust it to suit the characteristics of a HDR display. Please note, best practice when creating multiple deliverables is to start with the color grade in the larger color space. It's going to be easier to create an SDR grade off of our HDR grade than it is the other way around. And the second thing here to note is that HDR is not going to display correctly in this SDR screen recording. Now finally, if there's a clip that I need to troubleshoot by tweaking its color space conversion, I can disable color management for that individual clip by right-clicking and hitting Bypass Color Management. Now I can recreate my color management workflow using color space transforms. I'll put one at the beginning of my node tree and convert from my camera's color space to my intermediate color space. And then I'll put one at the end of the node tree where I convert it back to my delivery color space. Now I've got full control to tweak those conversions, and any grades placed between these two nodes are performed scene referred. Please note, you might encounter problems with this workflow if you're making use of timeline-based grades. Is color management optional? No, not really. Most editors and colorists are working with footage that has been delivered in a variety of color spaces. So whether you're using LUTs, node-based transforms, or project-based color management, you are managing color. It's worth considering though if your current color management workflow is preserving the integrity of your images and whether it's working for you or against you. Even if you're working with media shot in Rec 709 and you're delivering in Rec 709, there are advantages to adopting project-based color management and color grading scene referred. You will be developing a consistent and scalable and sustainable workflow that you can take with you when you eventually transition to working on HDR content or log-based media. Please note, there is still a place for non-color managed workflows, for example, if you've got legacy tools that are critical to the job that you're doing. A lack of understanding of the color management process might lead some people to believe that it is a creative choice. No, color management is a technical process, not a creative one. So why wouldn't you use the most effective and efficient way of doing it? It's worth considering. To finish off, here's a couple of scenarios to consider. Maybe you've heard someone say something like this. Scenario 1. I like to normalize the image myself by adding contrast and saturation. Well, hey, if you like the results you get, who am I to argue? Results will vary. Some log spaces are easier to normalize this way than others. For example, Cineon log is designed to be easy to grade. Don't forget RE-log-C is very similar to Cineon. But please remember, log images are more than just low contrast, low saturation images. An uncolor managed log image displayed on a Rec 709 display was never meant to be the starting point for your grade. Log images are cleverly designed to juice as much information out of a camera as possible. Scenario 2. I like to use RE-log-C as my timeline color space. A colorist may have got used to grading camera referred in RE-log-C 3, that's the original RE-log. Therefore, even if they have transitioned to a color managed workflow, setting their timeline color space to RE-log-C means their tools will continue to operate in a familiar fashion. But please remember, it's smaller than color spaces like red wide gamut and Rec 2020. So you might be bottlenecking your pipeline. And it's a color space that's designed for capture. It's not designed to be used as an intermediate color space. Scenario 3. I like to use LUTs. Fantastic. It's a perfectly acceptable workflow. But please remember the limitations of LUTs, what they've been designed for. You're going to have to find LUTs for each camera color space you work with. And given the Wild West nature of LUT creation, you're going to need to make sure you vet those LUTs. Make sure that they're good ones. And finally, scenario 4. I prefer node-based color management with CSTs. Undoubtedly, this is the most flexible and powerful toolset for color management. But remember, time is money. Most filmmaking is a careful balance of quality and economy. There's benefits to avoiding unnecessary complication. If project-based color management gets you the same result 99% of the time, but with a lot less complication, it's worth considering. I hope this video was helpful. On the one hand, we've covered some really deep topics. On the other hand, we've only just scratched the surface of color management. It's not possible to cover color management comprehensively in just a single video. And please, forgive me if for the sake of being concise, I've made some generalizations, cut corners, or not considered factors that influence your workflow. Now, if you have any questions, please leave them down below in the comments. Hopefully, I've equipped you with enough background information now that you can make informed decisions about your color management workflow. That was my goal, not to just give you a bunch of rules that you could go apply, but to make sure you understood the theory behind color management. As always, this content does take time to produce. So if you found it helpful, please give it a like, consider sharing it, and of course, make sure you're subscribed so you don't miss out on future videos. And if you or your company have specific training needs that you think that we can help out with, please get in touch. Thanks for watching. See you soon.